it's not going to be easy to address an audience like this as a philosopher. The likelihood to say something silly for at least one of you is so high, I'd rather not think about it. I've done my best to address the question that you find on the slide. Therefore, try to clarify at least to my own satisfaction what bioinformation might be. And I've tried to do that by being clear. Philosophers are not well known for being clear, rather notorious for being obscure. So, in order to achieve that, let me just begin by apologizing. If you remember, I'm sure you do, Schrödinger in his classics apologizes several times for not being a biologist. Well, I think I have to apologize twice, because I'm not a physicist either. So I don't have even that advantage that Schrödinger had. Now, what a philosopher can try to do is to be at least conceptually clear. So here's what I'm going to present you with, and every now and then during my presentation I will come back to this slide to pinpoint where we are in our little journey. So if this looks like a walk through a gallery, it really is. And if you find that a few points are a bit sketchy, they're meant to be, so that you are kind of enticed to read the eventual paper. I shall start by clarifying a little bit what we mean by information. Nothing new here. It's just a matter of agreeing on a vocabulary. Then I will address 4 specific problems that philosophers have found interesting when talking about biological information. This will be outlined under 4 different headings: biology versus genetics. This is a problem that we have with theory, where to place biological information. Then there's a problem with language. When we talk about biological information, whether we mean biological in an attributive or predicative sense, more of this at the right moment. And there's a problem with levels of abstraction, at what point we talk about both biological and information, and sometimes there's a little bit of confusion between the syntactic and the semantic level. I shall clarify that too in due time. And finally, a couple of issues concerning ethics and bioinformation. Why bioinformation is considered to be an exceptional problem, not just any ordinary problem. Once we've seen these 4 issues, we are left with the issue, with a particular question: what is this bioinformation? And I will propose a possible solution in 2 steps. Try to say what biological information is not, and then what it might be. We shall see that the last, most difficult step, and I apologize for that, is the conclusion, where I shall try to clarify what we mean by bioinformational structural realism. This is a huge hook or reference to contemporary literature in philosophy of science, and I will do my best to summarize the main points at that stage. But that will probably be the one which, part of the talk that will be less comprehensible for the non-philosophers. So I apologize for that too in advance. I understand we have about 45 minutes, and I will try to run on schedule as a good train. So let's begin with the vocabulary issue, namely agreeing on what we mean by information. Now you will see in a moment that even philosophers are confused about this, even philosophers who make a profession out of talking about information. There's a clear sense in which information is at least 3 different things, and I would not like to have you thinking that that means that we have 3 boxes and your piece of information goes either in box 1, 2, or 3. It's more like having 3 dimensions and placing in a continuum your piece of information in this 3-dimensional space. Let me be a little bit clear. Well, sometimes what we mean by information is information as a piece of reality. Something outside there is also called ecological information, natural information. You have patterns, fingerprints, tree rings, just to calculate the age of the tree. It's something that you find out there. So you talk about, for example, your fingerprints as information, which is slightly different from what we're going to see in the other two senses. So sense number one. Sense number two, which is also very common, we talk about information as something for reality, and there will be a command, an algorithm, a recipe. I call my mom, I don't remember how to make pizza, she tells me that's a piece of information that comes as instructions. She doesn't tell me that a pizza is such and such, she tells me do this, this, and that. Now that is information, but comes as an algorithm or a piece of instruction. The third sense is also very classic, ordinary. I want to know when the train leaves from the station. That's information about reality, and it has an epistemic value. It's what we build knowledge from. We start with some information. If that information likely is reliable, turns out to be true, then we build in terms of justification and so on. Now, as I said, these three, call them dimensions or different ways of talking about information. They come in a space. They're not three boxes. So that sometimes your fingerprints could be about who committed a crime. So it is a piece of reality out there, but it is also about someone. Or, as I said, a recipe could be just a description of a particular sweet that you like, but it's also a set of instructions. So what we shall concentrate our attention on is the meaning Z, the biological information as information for reality. Now this is not uncontroversial. I should probably, if I were to sell this point more easily to you, hide the fact that what I'm going to say, at least for philosophers, is debatable. Some philosophers would actually disagree profoundly with what I'm going to say. But here's the story. I'm going to tell you, try to convince you that the information that we talk about, when we talk about biological information, is information as a recipe for something. Examples of bioinformation in this particular sense, as information as reality, patterns out there, for something. Well, genes are bearers of information, or genes contain programs, or genes are informational instructions for the development and functioning of organisms. That's a typical stuff that you find in textbooks, I'm told. So here is the first step. So at least we know what we're talking about, hopefully. We move to the full problems. As I said, I'm going to tackle one by one, so I will send you reminders when we move from one problem to the other. Biology versus genetics. Well, when we talk about biological information, we know that it's at least using at least three contexts. You find them about biological information in animal communication, pathology. The usual example, bees. I don't even read it to you. You know it too well. The dance around, that's a kind of biological information that is prone to be interpreted as communication, etc. You also have ants smelling in a particular way, and so forth. Then you find biological information in neuroscience. For example, computational models of different various neurological systems that are involved in memorizing, learning, perception, etc. The neuroscientist will talk about that kind of information as biological information. And then you have genetics, reproduction and evolution, for example, molecular biology. Then again, in that context too, you find biological information. Now these are different contexts that are related, but also need to be kept separate from each other. Otherwise, it becomes a big soup. What we are interested in is biological information understood as genetic information. So all I'm going to say in the following slides refers to information as instruction and information, biological information within the genetic context. There are three issues, however, that I'd like to clarify before moving forward. Can information be reduced to communication? Look at point number A. Not really. So let's not get confused. Information is not just communication. Communication is not necessarily just about information. The two things are obviously related, but it's important to keep them separate. Is there no information in a lifeless universe? In other words, without us, or at least without animals, or at least without something alive, it would be meaningless to talk about information. Some people go all the way down, a number of references here, and say that without at least human artifacts, there wouldn't be any sense in talking about information. And that doesn't really make too much sense as far as I'm concerned. Think about food. Does it make any sense to talk about food without animals which treat that stuff as food? Well, in a way, no. If there's only grass and the only animals around are us, grass doesn't count as food. At the same time, we know that grass, if we were to find a planet with plenty of grass, could count as a potential kind of food for animals. So obviously, now asking whether something is or is not there without the user of that particular something, it's a little bit like asking the wrong question. In other words, food or information are concepts that relate items. They relate a user with some stuff that's being used. They relate the circles in the tree which has been cut to someone who is able to understand that this rings means ears. You don't ask whether those rings would mean ears without human beings around interpreting those, because you would just be missing one of the two halves of the full picture. And finally, can there be a unified theory of biological information that captures all the three meanings, or the three areas, or rather all the ways in which information is used in A, B, and C? As far as I'm concerned, I don't think so. No, at least you're going to be so generic, so open-minded, so flexible, that you lose any value in the concept of biological information. Now, this is not new. Shannon was already arguing for a very cautious attitude towards the concept of information. He thought that there were several meanings and several theories that would probably complement each other, but would not overlap entirely. It's just a reminder that we shouldn't be so easygoing when we talk about this concept, as if we should have a full theory of everything. So these are the biology versus genetics. As I said, we're going to be interested in see the genetic sense of biological information. Attributive versus predicative is more about language than concepts in my presentation. But what I mean really is something that is much deeper than just the way in which you use English. Speaking of biological information, can be confusing. Let me show you a recent article so that some evidence is out there. I'm sorry if anyone knows the author. You don't have to read it, and I don't have to read it to you. All I want to point out is that in this particular introductory piece, you find the concept of genetic information used several times. DNA sample, genetic information patented, genetic information to family members, personal genetic information. And if you're careful enough, and it's the author of the article, What is Genetic Information, Why It Is Significant, there's a concept of information about, information for something, information about something, information as something, information about something, information as something again. Now, as I said, this becomes a big soup. If you're not careful, you're mixing up so many different concepts, asking different questions that by doing that, we just simply make problems which are really complex impossible to solve. Now, what's the problem here? We need to distinguish clearly about what we really are interested in. We don't want to mix up the meanings of information. We don't want to be confused about the context, neuroscience, communication, genetics. We don't want to be confused about two different ways of talking about biological information. The distinction that I'm going to introduce is not merely linguistic, but it's much easier to introduce it as a linguistic distinction. So, as two different uses of biological as a word. You can use biological, sense number A, biological information, as information about biological facts. The database which contains some facts about, say, your DNA. Or you can use biological information in a predicative sense as something whose nature is in itself, intrinsically, sense A is commonplace in bioinformatics. We use it all the time. It's not controversial. It's not a problem. In fact, it's uninteresting. Nobody disagrees about the existence of this biological information, and it's really analyzable as a mix of syntactic and semantic theory of information, which is perfectly fine. In other words, we have the tools and the understanding to treat biological information in the sense of, information about something that is biological. The second sense, the predicate sense, that's open to debate. In other words, we discuss whether any biological facts actually count as informational per se. So it's not a matter of having or not having a database on certain kind of facts. The question is whether those facts themselves are of an informational nature. So the question asked there is what sort of informational stuff they are, those biological facts, if any, what kind of information theory is needed to capture their nature. Again, I'm not talking about a database, I'm talking about a sort of, reference of that database. And it is controversial, at least within philosophical circles, whether biological processes and elements are intrinsically informational rather than just interpretable information. Think about the following distinction. My stomach might be modeled as an information process, input, process, output. Is it really informational in itself? Of course not. Or at least not so obviously. So the question is not whether you can interpret something informationally or whether something is about something else and per se is informational. The question is, those facts, those biological facts that we're dealing with, are they themselves informational? Consider the following distinction, for example, between digital information. Digital information means information whose nature is digital doesn't have to be on digital facts. I could have digital information about a continuum. I could have digital information about the sound that I'm emitting right now. Different would be if I had digital information about something that is self-digital. For example, a software that runs on a test about another software. So we need to be careful about the context, biology versus genetics, attributive versus predicative, and the syntactic versus semantic level. And that's where the levels of abstraction and the different theories of information come to play an important role. As I said, we are interested in the predicative sense of biological information, not the trivial sense in which you attribute biological to information. Of course, that's obvious. The sense in which something out there in the world which is biological could also be intrinsically information. Now, there are many theories of information, as we all know. This is just a quick reminder. The three most commonly used, again in this context, are the mathematical theory of communication, Shannon, poor guy, I mean, he ended up by regretting having ever spoken about information, as you know. The confusion caused by that was immense. His original article was mathematical theory of communication. Syntactic theory, based on probability, works on signal transmissions, processing and storage, independently of their content entirely, does not concern either truth, meaning, relevance, or significance of the signals. And that's something that we need to keep in mind. There's a semantic theory about Hill, Canap, Dresky, my own contribution, which is only partly quantifiable. It's based on several various semantic models. For example, model semantics requires meaning, relevance, significance, and truth values. So it's just the opposite of Shannon as well in the spectrum. And then you have something like the algorithm theory, Chaitin, which really defines information as the minimum bit statement that describes the given output on some agreements about the sort of language that you use in normally Turing machines and so on. Now, if we look at each of them, here's what happens. Mathematical theory is insufficient. I'm not saying it's not necessary, but it's insufficient to discuss biological information since the latter seems strongly dependent on the concept of instruction, which is left untouched by the theory. M, the mathematical theory of communication, at most provides some useful modeling, but it doesn't represent a sufficient tool to do what we need to do in biology. It's a little bit like talking on Wimbledon by using Newtonian physics. That's good. It does capture a few essential bits, but there's a lot more to be explained than just the Newtonian physics that is at stake. The semantic theory doesn't help at all. It's irrelevant to discuss biological information, since the latter does not contain meanings or truth values. I mean, genes don't come with labels like true or false. It at most provides some metaphorical explanations and heuristics. Things get even worse when all this stuff is interpreted semiotically, and you find plenty of philosophers doing that. The algorithm theory just doesn't apply at all. It's not relevant here, so it doesn't help. So basically, what we find is that only the mathematical theory, basically Shannon, gives us some help in modeling what we need to model. Fourth problem, ordinary versus exceptional, and we're getting on the applied side. Well, there's a lively debate, as you are well aware, in contexts called information or computer ethics, concerning the use of biological, i.e. Genetic information. In genetic information, what seems of great ethical relevance are two specific facts. The first one is how malleable information is. The fact that information is generally easily manipulated. That's a little bit scary. And the second fact is that the genetic nature of the information in question is especially sensitive and worthy of ethical regulation. These are the two facts that normally are taken into account in the debate. Find something that is easily malleable on the one hand and plays a crucial role in determining the life of human beings. Point B is called, in the context for the ones of us who are non-philosophers, the genetic exceptionalism. Why genetic information is so much more exceptional than any other kind of information that we deal with. Now the question is whether genetic information ought to be regulated in any special, distinctive way. In a way distinct, for example, from the way we regulate patents or copyright. The problem here is that the predicative versus attributive confusion creeps in. Remember, it's not about or just the database about human beings, but the fact that those human beings are constituted at a biological genetic level by information that plays also a role. Here's the example that I provided you before. Digital information is not information about something digital, not necessarily. Medical information, on the other hand, is information about medical facts. And there are cases in which you have both combinations. You have military information, which is both information about something military, and because of this, is of military nature in itself. Now this might seem pretty simple and, in fact, rather stupid examples, unless we keep them constantly present in our minds. The confusion, which we have just seen in the previous slides, is immense. You try to legislate on what genetic information ought or ought not to be, or how we should operate with genetic information. You get confused about these distinctions, the mess is depressing. So, let me recall you, predicative versus attributive use. When these two meanings are independent, and often they are, when they are independent, then that's fine. When they are not independent, then the predicative use cannot depend on the attributive use. It's rather vice versa. It's the attributive use that depends on the predicative. So what we find here in the genetic issue is what might be called the priority thesis of the predicative of the attributive nature of biological. Attributive biological information and predicative biological information can be either independent from each other, think of the database and something else, or the attributive use of biological information depends on the predicative biological information, not vice versa. In other words, just to put it simply, if you have a CD with biological information that's predicative in a sense that, for example, it could be of a biological nature because it refers to something else that is biological, not vice versa. Now this, again, simple, not big step, but what follows is of interest. Because if you accept this thesis, which is, I would say, not very controversial, then genetic exceptionalism is justified not semantically, not in terms of what we mean by X and Y, but ontologically. It's a matter of what we are dealing with as stuff in the world, not what kind of meaning we attach to a particular database that makes a difference. Genetic information ought to be regulated in a special, distinctive way because of what is in itself, not because of what it is about. Now, I hope this distinction is sufficiently clear. It's not just because it speaks of my nature, for example, that my DNA is something that ought to be regulated carefully, but because it is my nature. So we left now, with all these clarifications and specifications, with the original problem. What is biological information? I said that I'm going to incline towards a alternative meaning, and that what we are interested in is the P, or predicative use of biological, when biological refers to stuff out there which is intrinsically biological. What could that be? So, reminded, we reached point number 3. We're doing quite well in time. And at this point, I'd like to suggest a road which I don't find particularly fruitful, on one hand, first, and a road which I think is a little bit more helpful next. So what biological information is not, or at least what I think should not be. As I said, biological information in the particular sense, stuff that is intrinsically out there biological, is procedural. It's like instruction. The DNA contains the genetic code, as we all know, precisely in the sense that it contains genes, which code for the development of the phenotype. So DNA contains genetic information, roughly like a CD may contain some software. Now this is definitely not controversial. It's the next step which might find some of you in disagreement. Because the genetic code, once we make the step, or better the genes, are the information itself. Genes do not send information, no more than a password sends any information to the system it interacts with. Imagine a password or a key for a particular lock. The key and the lock are not related in terms of message and receiver. The key opens the lock, and that's the way in which it is interpretable as information. So like a password, genes work or don't work well or badly, if you want to be a little bit less Boolean, but they do not send or fail to send the right message. And genes do not contain information in the sense in which envelopes or emails contain information, no more than a performative does. If I tell, I promise to come at 6 p.m., well, that performative does not really describe constitutive function. It is 6 p.m. That's constitutive. That's I'm describing a piece of reality. It doesn't really describe a piece of reality. It contains a promise. It rather does something. It affects the promise itself by uttering those words. So it's like baptizing something. If I baptize this pen, the Queen's pen, well, this pen is going to be called the Queen's pen since it doesn't describe this pen as the Queen's pen. It becomes the name for the object. So genes are not information in any semantic, descriptive, or constitutive sense, and they do not merely contain or encode instructions as a string of lines and dots may encode a message in Morse alphabet. And then again, you need to be, or we need to be careful about all this, because remember, we want to be able, at the end of the road, to legislate on how to use human genetic information. So that's what they're not. They're not like envelopes. They're not like descriptions. They're more like promises, instructions. Let me try to be a little bit more specific. And there's a little bit of philosophical jargon which shouldn't scare anybody. It just means, ontic just means having to do with reality. So if we have an ontic interpretation of genetic information, where genes are the instructions are a type of predicative and effective procedural information, recipes, software, commands. That's the family to which genes belong. The first slogan that I'd like to leave you with is, in the genetic code, the medium is the message. If that sounds familiar, it should. everyone had it upside down, but that's really what happens. You've got a medium, and that medium doesn't carry the message. It is the message itself. There's not a second sort of level that is being transported by. The genes are the key. They do not provide instructions of where to find the key. Again, as everything in philosophy, we should be careful because every philosopher sells you things step by step. And the first step sounds kind of okay, the second okay, and at the end of the road you find something absolutely absurd that you bought somewhere on the way. So there are two implications of this idea, the first slogan, genetic code, the medium is the message. The first one is a shift in the informational paradigm, which I'm going to show you in a moment, and I think that that can be defended a little bit more successfully than the second implication, which is a little bit more controversial. Namely, we can provide, or try to provide, a unification theory between two ontological domains, physics and biology, if we buy this genetic code is the medium, not the medium is the message. Let me explain both implications step by step. The ontic interpretation relies on the procedural programming one. Now, for the computer scientists among us, that's what I'm going to say will sound absolutely trivial, and I apologize for that. So, at the moment, we're treating genes as dynamic procedural structures that control and guide organisms' development. They do not carry information, they are the information themselves. They are like instructions. They work like a promise. These dynamic procedural structures are a special type of informational entities, those that are in themselves instructions, programs, or imperatives, and this is where the link comes handy. In imperative programming, also known as procedural programming, statements change a program state, and programs are a sequence of commands for the computer to perform. Do this, do that, wait, go to, start again, do this, do that. And in that kind of sense of procedural programming or algorithm, that's where the link between programming, computer science, and biology, instructions, genes, comes as a bridge. We can move from one to the other by understanding that the sort of information we're talking about is not like a timetable for the train. And it's not just like patterns out there. It's more like instructions that in themselves are effective for something to happen. So each step, each base, our biology, is an instruction, and the physical world holds the state that is modified by the instruction. So it's basically like having keys that open locks around. The relation between instructions, genes, imperatives, programs, recipes, and the outcome is functional causal, meaning that you can start building laws or interpretive laws because what we're dealing with is nomic. There are regularities of if-then. So that's what happens, and it's quite useful in terms of shifting the paradigm. When you talk about information, the first thing that what people would go to is Shannon, information theory, communication theory, usual model, sender, message, receiver. Well, that's one side. But what I'm suggesting is that we should shift to the computer science and the imperative programming as a better model. Let me now illustrate the second implication, and this is where I said I'm going to be a little bit more philosophical than I've been so far. References to contemporary literature in philosophy of science are inevitable at this point. I said that the second implication of this long story that I've been telling you for the past half an hour is that we might be able to unite two contexts, two ontological domains, physics and biology. Now, to do that, obviously, it will require some abstraction. So, structural realism, so that we all share the same first step, is a well-known, relatively uncontroversial, as far as philosophical theses go, position in philosophy of science. It started with Russell and developed forward. Now, one of the great advantages of understanding the genetic code in terms of informational procedural structures is that this allows one to adopt a unified information perspective for the whole reality, both non-living entities and living entities, bias. This information ontology, which I will label informational structural realism, is what helps us to build the bridge. Now, here's information realism in one sentence. The next slide unpacks and unzips this particular sentence. Informational structural realism is a version of structural realism supporting the ontological commitment to what you think is out there. The ontological commitment to a view of reality as the totality of the informational objects dynamically interacting with each other. In other words, it's like thinking that the whole universe is, at the bottom, informational in itself. That's simplifying, but that's basically the story. So, as I said, to unpack that, information realism in general argues that our knowledge of the world is knowledge of its structures. You don't really know things in themselves, you know the patterns combining things. Endorses a first-order ontological commitment to the level of abstraction at which the structural nature of reality is knowable. In other words, to unpack that too, you think that ultimately reality is knowable, but is knowable only insofar as you know the structures that are out there, not the things in themselves. And a second-order ontological commitment to the level of abstraction at which relata are informational objects. Then again, to unpack this too, this means that the objects that you think are being structured in these networks are in themselves not substantial, but made of relations. Also argues that knowledge, reality is a source. It's not a source of knowledge, it's a resource. Now, this is what I think. It's kind of a linguistic game. It's something to be used, manipulated, processed to obtain knowledge. It's like building material for your knowledge. Goes, things in themselves, what Kant used to call noumena, are unknowable in the sense that as resources, they are epistemically inexhaustible. They're not inaccessible. It's like having a fridge that is always so full of stuff, you can cook anything. Now, you don't mean that the fridge, you can't open the fridge. You can open the fridge and get anything you like from the fridge. Have you ever exhausted the fridge in itself? No. The fridge is so full of things. You can keep cooking and cooking and cooking. And the cooking tells you something about the fridge and its contents. But it's not a picture of the contents of the fridge. So, according to this information realism, there are two ontological commitments. The world in itself is this full structure of affordances, constraining affordances. Remember, it's like food in the fridge. Depending on the food you pick up from the fridge, you can cook certain kind of things. If you need an omelette, you're going to get eggs. You don't try to get eggs by picking up a bottle of white wine. It won't work. I tried. And these are the things that are dynamically interacting with each other. So these are resources out there that you use in order to build your knowledge. Now, in that whole picture, how do we build this bioinformational structural realism? What I told you is just a 5 seconds packed mini course in information realism in philosophy of science. Well, what the final picture is that the difference between not animated and animated informational entities, like this thing, and living informational entities, I could count as a good example, is the anti-anthropic nature of the latter. Now, this is not new, at least as old as Schrödinger. But there's going to be a twist. Now, a living system is any anti-anthropic informational entity, that is, any information entity capable of instantiating procedural interactions, because it involves information processing operations, in order to maintain its existence and or reproduce itself through metabolism. And then again, this is quite okay. What we have now is the second slogan. The second slogan goes like this. According to bioinformational structural realism, life is the economic process through which information uses itself to withstand its own entry. If you have a view of the whole universe as being at the bottom, information, then life is just that area, that piece of the universe where information uses itself to withstand the inevitable process of entry. And that's where things get a little bit smoother in the passage between physics and biology and back. I think that's it, and we have some time for questions. Thank you very much.
papers up for discussion.
Okay. It's clear with your philosophical classification of information. My question goes to one biological aspect. You say that genes control and guide organisms' development. This is a kind of metaphor, technical metaphor used in the linear understanding of information, reflecting the main or central dogma of molecular biology. When we see that information transmitted in a linear way. But nowadays, we understand that information in the living system is a circular information. The genes are controlled. Any express of gene is controlled in the whole developmental system. We have the theory of autopoiesis, at least, which also stresses that genes are nothing without controlling by the whole body. So, to this respect, imperatives for what are genes, what they instruct, if they are instructed themselves. I wouldn't ask you this question if you were a biologist, but as a philosopher, you have to put this in absolutely different light, that genes not instruct anything. They only are part in the whole circulation of biological information, and this biological information cannot be reduced only to genetic information. So thank you if you speculate on this topic.
Yeah, let me put it this way. It's always easier to make things a little bit more complex. It's like what I provided is kind of pizza margherita. You can put anchovies and whatever you like on top of it. That's fine, as long as you have the pizza margherita behind. In other words, out of metaphor, what I mean is, I completely agree with you. But that is not an objection. It's just making things a little bit more precise and complex and articulated and finally tuned to the contemporary knowledge that we have of biological interactions, which are systemic, which have feedbacks, where the control is not just here or there, but is possibly even emergent from the whole system. This is all, if I think we all agree on, or at least both of us agree on that, including what you just said in terms of not pointing to genes as the only, or perhaps not even, suppose, in 100 years, not even the main source of whatever we need in terms of genetic information. That doesn't change the fundamental story. In other words, it's not an objection that would force anyone sustaining what I've just sustained in terms of saying, oh, oops, that's the wrong direction. It's the same direction, it's just much more better shaped, much better tuned to our knowledge. If we say that genes are in themselves instructions, we're not saying that they are the only instructions available. We're not saying that our instructions, they have no source which is instructing them. We're saying if you look at genes in themselves, they work as a promise, a piece of software when we're talking about software that does things that just take and so on. So I don't want to sound cheap, but I completely agree with you without having to change my mind.
May I ask one more very short question? It looks very contradictory to say information is anti-entropic. As we know, information means anti-entropy. So cannot be entropic information. You just put anti-entropic information, but information cannot be entropic. Everything which connected with information is anti-entropic, order creating. Okay, thank you. That's my last question.
Yeah, I really didn't want to add any more distinctions to my talk. As you probably know, and most people know in this room, there are so many ways in which we talk about entropy. Now, obviously, one classic way is in the thermodynamic sense. Another classic way, which is related but not identical, is in information theory. Now, when I said at the end of the talk that information and life is where we have this anti-entropic sense, what I was referring to is the local capacity of living organisms to withstand for a little while, in a local sense, this natural entropy that is basically transforming the whole universe in a more stable, less interesting place. That's what I meant. Now, if you want to say that there's a contradiction saying that, yes, if you like that, we can just agree on the vocabulary. But I wasn't going to give a lesson in Oxford English Dictionary. Yes, I didn't mean that.
two comments and would appreciate your responses to them. The first takes off from the comment that was asked earlier, and this has to do with looking at biological information, in particular genetic information or DNA information, in the sense of instructions or programs. Now, it seems to me that there's a problem with this point of view, which is that any even metaphoric use of the word instruction or program carries with it a notion of purpose or a notion of goal or design. And everything we know about evolution tells us that that's precisely the wrong way of looking at life or living systems. That's my first comment. The second comment is, I wonder whether your notion, the way you look at information, can in some way be related to something which I think originated from Konrad Lorenz, which is to think of signals, informational signals. And he gave a rather tight definition of the term signal, which I think is fairly commonplace among behavioral biologists. So he said something was entitled to be called a signal if it elicited a response in another individual, and if that response was favorable to the individual that sent the signal. I have a feeling that information, the word information, can also carry connotations of signal. I wonder whether you could comment on these two remarks.
Oh, these are very useful, both remarks. Which basically, you provide the answer to the second remark to your first question. I agree with you that if information understood as instructions were to be understood in any possible way as teleological, goal-oriented, then we would be on the wrong path. I mean, it doesn't make any sense. We shouldn't be doing science in that particular way. Maybe that's the end of the story. Maybe there's someone out there who's building the whole business. That's not the way in which we carry our work in biology. We haven't done that for some time. We shouldn't start doing it again now. So I agree with you that anything that has got to do with information as instructions that would link that particular sense to the sense of goal-oriented, teleological, would be a mistake. So if we could possibly agree that the sort of instructions that I was talking in this presentation are the signals that you were mentioning as referring back to Konrad. In other words, responses, questions and answers, or interactions that elicit a positive answer on the other side. I'm perfectly happy with that. I would call that instructions, but if you feel that anything that has got the meaning of instruction has to have an end or a goal, preset or selected somehow by someone who has made the whole machine for a purpose, that's not my intention. So I think I can perfectly go with you and change the whole talk and talk about signals as having a positive, etc., etc. That's what I meant by instructions there. There was no meaning of some sort of end in itself, goal-oriented necessarily. Having said that, we know that it's easy to fall into the trap of talking about nature as having some goals or getting or going somewhere. Sometimes it's just easy for sort of communication purposes to say that horses have four legs because they can run better with those 4 legs. Of course, it doesn't make any sense in that particular way. It's just a way of sort of, making each other understand what the point is. So, back to the second point, I think I much appreciate your suggestion of talking about signals, and in fact, in the final paper, I could probably pick up some more information from you about it.
Well, one of your slides had a question having to do with whether information exists in a lifeless universe. And when something like this, the statement implied a question. No information exists in a lifeless universe. And the answer to that question was no. And then you gave an example of food for a microorganism which could not exist in a lifeless universe. I was confused by that. I wondered if you clarify.
Yeah, I'm sorry. The part of the confusion is due to the fact that I was trying to give 3 no answers. So I phrased the 3 questions as 3 questions to which the answer was no, no, no. So you're perfectly justified in having picked up that rhetorical device. Basically, there has been quite a lively debate, again, mainly in philosophical circles, I understand, about the issue, quite simple, whether it makes any sense to talk about information in general without human beings. Now, of course, if it doesn't, as some people have argued, then all the biological information, etc., doesn't make any sense either. In other words, it's quite simple. You take away human beings from the universe, no sense in talking about information, no sense in talking about, for example, zebras having genes, etc., bioinformation. So, now that sort of line of argument, which might be sort of a bit philosophical in the worst sense of the word, I was trying to argue for a mid-ground between yes there is, no there isn't. And the mid-ground seems to me, I was providing the food example, as there's plenty of relational concepts that we have which require the existence of A and B to be in place. The concept of food is one of them, and I was hoping that that could be an easy sort of analogy. It doesn't really make too much sense to talk about food without having A and B. You need to have grass and grass eaters to understand grass as food. Grass with only us around, or tigers, is not food. End of the story. Or is the aura that interests me. The difficulty here is that often, when analyzing concepts, including information, we fall into the trap of saying, well, is either there or not there? Some things that we deal with, the more subtle things, sometimes are just on the border. The threshold between one country and another is neither that country nor in this country. It doesn't mean that it's not there. It just, you need the 2 countries to have the threshold over the border. In this way, food, you need that particular organism and that particular stuff that will match the organism needs. Now, information seems to me, at least insofar as I'm interested in this concept, that is one of those liminal or relational concepts. You need to have certainly someone who reads the trees and the circles, but at the same time, the circles and the trees are out there. And again, being captured in the alternative, is either there or not there, is either there independently of us or not, seems to be the wrong attitude. So I was trying to strike for a third position between yes and no. The no answer was, no, it is not true that there is no information in the world without us, for the simple fact that it doesn't make sense to ask that particular question, since this is a concept that has 2 legs. It needs both items.
In relation to your answer and Dave's question, Susan Oyama described ontogeny of information. It means that information itself is showing some developmental processes between so-called lifelike system and surrounding system. So from a point of view of complementarity, such viewpoint may be very important to understand further direction. I'd like your comments or your opinion. Do you know Susan Oyama's ontology of information?
No,
Generally speaking, people usually consider that information is existing in some material basis, but Susan Oyama considers such things is one side, just looking at one side, the true story must be considered dialectic process between the 2 opposites, instead of staying on the one of the opposite states.
I think that what you're saying is, first of all, I must confess my ignorance. I was not aware of that particular piece of work. So I think there will be more to talk about after the break.
Okay.
Before I leave the audience, a short comment. And this is that, yes, and insofar as I understood the position, that would definitely resonate with what I was saying here. In other words, you could look at evolution from an informational perspective and look at organisms as just one instance of the evolution of information in the universe. So evolution would move from inert and so on, all the way down to living organisms and perhaps mental living organisms. And there would be just the evolution of informational entities becoming complex, capable to corporeality, more something or less something. Okay? So basically, as far as I could tell, thank you, that's very relevant.
Thank you so much.
I think, was there another question, or I'll observe the chairman's? Oh, okay.
I thought I was hopeful.
No, not yet.
I enjoyed your very witty and clever talk, but I'm confused. After you leave the via negativa of what information is not, and you start to tell us what you think information is, sometimes you speak of information as, to use your words, knowledge or information, description. At other times, you use the words command and causal. And are there two different types of things that we want to call information, or am I missing something?
Oh, no, thanks. If I said anything at the end of the talk in terms of information as knowledge, by mistake, forgive me, that was not meant. Don't go out of this room thinking, oh, that's what he meant. Not at all. When it comes to genetic bioinformation, that kind of stuff out there, the DNA and so on, the genes, all I meant was there's one way of understanding the stuff out there, which is looking at the concept of information instructionally. I hope this is sufficiently sort of wide and open for further agreement on the previous initial question. But basically, it's saying we have three roads in front of us when we talk about information and genetics. You can go in terms of knowledge, something is true, meaningful, that's a bad idea, but nobody went down there. So you can talk in terms of patterns. That's something that's already going kind of almost in the right direction, if only we could join that to the instructional perspective. In other words, yes, the stuff out there doesn't carry information as instructions, it is instructions in itself. So all I'm really doing here is shifting from a better level to an objective level. It's not saying these are the genes and this is the information that they carry, these are the genes and they are the message.
So information is causal.
Perfectly fine, yes. And it's instructional in that particular sense. Really, it seems to me that the only controversial point here is whether we want to draw a distinction between genes, genetics, biological information, and so forth, and the stuff that is brought about by this, instructionally, or, as I'm trying to argue, not drawing any difference between the biological stuff, the biological patterns, and the fact that they themselves are the instructions. So there's no difference, basically, metaphor, between me baptizing something and that thing getting the name. Because the baptizing is not carrying something, is the instruction itself. So the gene is not carrying or encoding as an envelope, and you open the envelope and there's something inside. The gene itself is what makes the difference, is the key.
I know sterile and performative language and all the rest, but it doesn't work very well in Tibetan or Chinese or some other languages.
Of that, I'm painfully aware.
Thank you.
I'll exert the chair's privilege for one last question. You, at the beginning, you were very honest, and you said if there may be biologists who would agree with you throughout the talk, at the end of the talk find themselves in a strange place, which I am. And that is, you did say that the non-tech interpretation unified biology and physics. Now, the genome is not all biology. There's emergent properties. There's nothing in a genome that predicts population ecology. And so at that end, there's nothing in the genome that could predict string theory. So what exactly is meant when you say unify biology and physics, when one cannot predict more interesting aspects of the other?
No, it's absolutely fair point, in fact, important point. Does that mean I cannot answer? The unification I was referring to there is in terms of, unfortunately, philosophical unification, in terms of the sort of language that we can share between the two philosophies of. When we talk about philosophy of physics, there's a lot of, for example, talk about determinations, particles, waves, etc. And we really find a difficult time in sort of putting that together with the vocabulary, the conceptual vocabulary that we use in philosophy of biology, when there's concepts like life, adaptation, and so on. Now, these two things is the hope of the sort of project here that I was presenting, could be brought back to a unified language, which is informational, where on both sides you're talking about informational entities, which of course then have completely different lives, and they go up to develop different complex properties depending on your level of abstraction, the context, and all the other sort of stuff that makes physics different from chemistry, from biology, and so on. But it's like saying, look, it's number theory, and then you can do calculus, you can do abstract algebra, but back down, there's an attempt to reduce everything to elementary arithmetics. Of course, that doesn't explain at all the complexities that expect us in each ramification. But there's an attempt, typical philosophical move. Philosophers move backwards, they never move forwards. They ask the question and they look at the roots. They don't ask the question and look at the leaves. Now, that's the difference between scientists and sort of philosophers to some extent. So here is an attempt to look at the roots and go further behind to see whether there's a single point where you can then ramify all the other alternatives. So that's where I was hoping, and I still hope, that we might be able to have an informational unification of the two ontological domains. By ontology, I mean the theory of the entities that are in question. So if we could reduce waves, atoms, particles, all the way down to informational entities, and we could reduce living organisms, all the way down to informational entities, then, oops, that's where we have a common vocabulary. And that's quite useful, at least philosophically.
I think we owe our speaker. And we are done with this session. We can come back at 7:30.